Hello and welcome to SDSU's One Water Center facility design brought to you by Dawn to Dusk Engineering. As the project manager of Dawn to Dusk Engineering, I'd like to introduce you to myself. My name is Jackson and I'm a wastewater engineer. And for the rest of our team, we have Callum, who's a water resources engineer and architectural design specialist. We have Matthew, who's an environmental engineer. William is our stormwater and land development engineer. Carson is our construction and site development engineer. And Ryan is our structural and geotechnical engineer. At the One Water Center, we're brought here today because water conservation has become increasingly important, particularly in Southern California. As the drought continues, we must use our water resources more efficiently and continue to utilize our improving technology. Dawn to Dusk Engineering has been tasked with designing a new state-of-the-art water laboratory for SDSU's faculty and students at the new Mission Valley campus. The One Water Center for SDSU's campus will serve as an educational and research facility for students and faculty where they'll be able to gain hands-on experience with on-site treatment of wastewater coming from the Snapdragon Stadium, in addition to providing an environment for researching for other opportunities that will allow for more efficient wastewater treatment processes. In addition, it's important to note that this facility will have received a Gold LEED accreditation based off of its design.
Hello, my name is Callum McCrae, and I'm a water resources engineer at Dawn to Dusk. This state-of-the-art facility will act as a valuable research resource to the university and as an educational center to the community. Featuring conventional treatment in the Dirty Lab, students will be able to see treatment processes in action, while faculty will be able to perform experiments because of the treatment train's plug-and-play capabilities. Researchers will be able to insert new and emerging technologies every step of the way into the treatment train with full control. The treatment train requires wastewater to be an effective educational tool. Our design for the One Water Center will include a pump station to bring a flow of wastewater coming from the Snapdragon Stadium into the facility for treatment. In order to choose the right pump type and specifications for the station, head loss between the sewer vault and building will be calculated. Pump curves will then be analyzed to choose a pump with the correct capability for our needs. The wastewater that has been through the treatment process that will be featured in the Dirty Lab will be discharged back into nearby sewer lines. This is because the effluent will not necessarily meet city requirements for other uses and should undergo further regulated treatment processes at a water treatment plant.
Hey everyone, my name is Matthew Makasadu, and I'm an environmental engineer here at Dawn to Dusk Engineering. Pictured below is the One Water Center site plan, which is developed by our stormwater and land development engineer, William Augustine. To the right, we have the proposed conditions for the project site, which include a reinforced concrete slab for two 5,000-gallon tanks, the proposed building, along with landscape, an outdoor field lab, AC pavement, ADA-compliant parking, and an underground rainwater storage tank, all within the construction site boundary, which is denoted by the thick black line. Moving on to the facility functions. The facility is made up of 7 core components. These are the Dirty Lab, the Wet Lab, a field lab with indoor equipment storage, a conference room which serves as a classroom as well, the technician's office, a locker room, and outdoor experimental areas for the use of planters and other natural water management strategies. Moving on to the Wet Lab and the Dirty Lab. Pictured below are 2 floor plans for the Dirty Lab on the left and the Wet Lab, which is on the right. At 1,500 square feet of semi-industrial space, the Dirty Lab shall serve as the experimental core of the One Water Center. Active research can be observed by visitors looking inside through a large, clear window. The Wet Lab follows a traditional biology laboratory space configuration at 1,500 square feet, and some notable lab equipment in here include fume hoods, research benches, sinks, and cabinets. Moving on to the technician's office. The One Water Center will be staffed and managed by a technician at least part-time. At 225 square feet, there's enough space for a desk and computer. The technician's office is located next to the Dirty Lab.
Hello, my name is William Augustine, and I am Dawn to Dusk Land Development and Stormwater Engineer for the One Water Center project for San Diego State. Our project will include a field lab and equipment storage area. The purpose of this area is to support ongoing field research done by San Diego State University. The area will include 3 outdoor sinks, which can be used to clean field lab equipment, as well as a 500 square foot covered storage area. The purpose of the covered storage area is to provide storage for field samples, field equipment, and prevent theft of items being stored there. Our site will also be treating 100% of its stormwater runoff. Calculations are still being done to determine the final proposed method of stormwater treatment. However, there is available land to meet a 3% minimum requirement for a bioswale BMP on the project site. We have also proposed an underground storage tank for rainwater reuse. Calculations are still being done to determine feasibility of rainwater reuse.
Hello, my name is Carson Knudsen, and I am Dawn to Dusk Engineering's Construction and Site Development Engineer. Here you can see the second floor building floor plan of the One Water Center, which is approximately 2,400 square feet of space and has both a waiting area and a conference room. The conference room accommodates up to 20 people for meetings and has floor-to-ceiling glass windows on both sides. This room is also going to be equipped with a television, a podium, a microphone, and a projector. Underneath that is the waiting room, which has a modern desk with ample seating for people and access to both the elevator and the stairs. Dawn to Dusk Engineering has used Autodesk Revit's software to create multiple renderings of what we believe this site will look like. Here you can see the overall building site plan with the front entrance being to the left, and to the right, a access road with the loading area and the field lab. Here is our dirty lab. You can see the fume hoods on the right on the wall, as well as ample seating, counter space, a sink, multiple tables, and lockers for storing personal belongings. Here is our wet lab with, again, ample counter space and cabinets for storage. To the left is a rolling door with access to that access road / loading area. And to the right is a glass window for anyone who is touring the facility to be able to look in and see what is going on at the lab at any time. And the final image here is of the conference room, which I alluded to earlier, with the 20-person seating arrangement, the television, and the podium, as well as the floor-to-ceiling glass window showing the beautiful view to the right. Dawn to Dusk Engineering has consulted with multiple vendors, as well as online sources, to try and create the most accurate schedule possible. And with that being said, we believe that this project is able to be completed in 230 ordinal days.
I'm Ryan Zwick, the structural and geotechnical engineer for Dawn to Dusk Engineering. Looking at the geotechnical data, it was shown through the boring log that a 2-foot layer of unfavorable clayey sand was present. Beyond this layer is a more favorable 7-foot layer of sand with some silt. As a result of potential soil expansion through moisture, the clay layer will have to be excavated and replaced with a more suitable soil, such as sandy loam or sandy gravel. This is to ensure that the slab and footings remain in good condition. This layer will also be expanded higher due to the Mission Valley area being prone to liquefaction. Additionally, the soil will have an assumed bearing capacity of 3,000 PSF, allowing for a code-compliant building. Moving on to the structural portion of the project, an extreme heavy-duty slab and footings will be constructed in order to support the 2 5,000-gallon tanks, key to performing experiments in the lab. The tank slab is planned to be disconnected from the building in an effort to keep foundation costs lower, as a lab building slab will be significantly smaller and less reinforced due to the weight requirements. It is planned for the tank slab to be made of 14-inch strong concrete and reinforced by number 9 steel rebar at 6-inch offsets. As for the lab building itself, the slab will be constructed in 2 parts, split between the 2-story section of the building and the single story. Concrete columns will be the main support for the building and will contain number 5 rebar. The walls will be made out of masonry and sheetrock to allow for a pleasing design. Included will be masonry shear walls to allow for protection from the lateral forces caused by earthquakes. As for the cost of the building, the current estimation comes out to around $3.2 million due to the high cost for a state-of-the-art laboratory, a small price to pay for the research that will be possible. From all of us at Dawn to Dusk Engineering, thank you.